if I didn't do the...
You did not have to show all this notation. Is that what you're asking?
No. As in, like in the answer key, it says, I don't know if you're looking at it.
Yeah, I'm looking at it.
On the right, it says f of -6 and f of 5. That just means you got...
Lucy and Charlotte.
You got f of -6 correct, and you got f of 5 correct. Even if you didn't necessarily do integration. Because for me, I did not do integration.
Well, pause. You had to somehow bring in a 7. Otherwise, there's no way you would have gotten this answer if you did not bring in a 7.
I don't even know what I did, but I got 3. I did something weird with slope.
There's no 7 written down anywhere?
There's no 7 written down.
I got 3 first, too, I think.
Then you probably would have had a check that was made wrong. Because you, at least for the initial condition, you did not use the initial condition, so you would have lost that point. If you got 3, if you technically wrote down 3, I suppose you could possibly get this point unless it was one of those checks that they had to make wrong because of something incorrect that you stated. That's the one dilemma. But if there isn't something incorrect that you stated, then you could have gotten the point for 3. Austin.
I'm kind of confused, like, why we switched the bounds.
Oh, because -2 to 6 is going backwards. I don't have the graph right here. -2 to -6 is going backwards. It's a B to an A. So you don't necessarily have to switch the bounds. This notation doesn't have to be necessarily written down. You could have just done 7 minus and had this whole string of all of your areas and just boxed it. So as long as you have the meaning of 7 minus 4, what you wrote encapsulates the 7 minus 4, you would have gotten this point and you would have gotten the initial condition. But what they're showing is proper notation. We don't integrate from B to A. We integrate from A to B, but to flip the bounds, we've shown it on the board a couple times now. To do B to A, we have to do A to B, and we make it a negative. We flip the sign. Sarah?
Just like a general question, when you go backwards without this negative before the integral, and you switch the bounds, right?
Yes.
But when you have like something under the x-axis, the value itself is a negative?
Yes. And so if you're moving on a graph like the one that we have, maybe I just shouldn't full screen it because I can't manipulate back and forth. This has a bound. It's reading the graph for someone who might be visually impaired. This is starting at -2. So Austin, here's the answer to your question. You have to start at -2 based on the clue. The clue is -2. So integration as net change would have this be our A. But if we're trying to get to -6, that's going backwards. So this area is naturally positive because it's above. But since I'm going backwards, if I ever have to go right to left, I have to make the signs opposite. So instead of this being a positive area, which would happen if I was able to move forwards, I have to, since I'm moving backwards, make it a negative. Now, as I move from -2 to positive, wherever I'm trying to go, 5, as I move from -2 to 5, then, yeah, Sarah, you're right. Since I'm moving this direction, whatever below is negative, whatever above is positive, put them all together. But remember, do you need to simplify? The answer is no, 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 no. Okay, back to the answer key really quickly. Any other questions that you guys want to ask? Letter D. Okay, letter D, I believe, was asking for, was it just asking for the second derivative? Okay, hold on, let me pull this out real quick to make life a little bit easier. Let me do this. Let me do this. And okay, find the second derivative, find the value, or explain why it does not exist. Okay, remember what we were talking about? If this is the graph of the first derivative, how do we get to the second derivative on the graph? Slope. So what is the slope at -5? Well, -5 is a part of this line. How do you find the slope of any line? y2 minus y1 over x2 minus x1. So I would use the point -2, 0. I'd use the point -6, 2, and I'd do a simple little rise over run.
So what stops you from being able to do that for part A? Looking at the slope for -6.
I'm not looking at the slope for -6. I'm looking for the original function value. So f prime of negative 6, the derivative of some original, the slope of some original, is found by going to negative 6 and stealing 2. For f of negative 6, I need to go backwards with integration. I have to think area. For f double prime of negative 6 or negative 5, I have to say, oh, hey, f double prime is the derivative of the quantity that I have. The derivative is the slope of the tangent line. So I go to negative 5, I see a line, I know that the slope can be found very simply with rise over run, and so I solve. Now the problem with f double prime of 3, that's a sharp point. And what's true at sharp points? Slopes, careful, don't say it, slopes do not exist, right? So the slope of f prime at 3 does not exist because of the sharp point. Could you have shown it with limit notation? Sure. Could you have stated that f prime has a sharp point at 3, so therefore f double prime does not exist? Sure. Both of them work. Sound good? Okay. So, kiddos, any other questions on the answer key? I heard D, I heard A, and we went over them both. Anything else? I'm a little worried that no one asked about the closed intervals on letter B. I think maybe someone asked about it yesterday, why the negative 6 was closed. Technically, I would have kept these open. I'm not exactly sure why there's the change in. I disagree with that change in. I probably should ask and reach out and try to figure out what's going on with that change in. It's ultimately 1 point, but here's the problem. This closed is important. This closed is important. The rest should be open. I totally agree with that. This closed is important, and let me show you why really quickly on the graph. It's asking, the question is asking where f prime is positive. Actually, I think it's asking where f is increasing. And so f is increasing when f prime is positive, and f prime is positive at negative 6, because at negative 6, f prime is above. So f prime is positive at negative 6 all the way up to negative 2, keep it open. And then from 2, keep it open all the way up to 6, 2, 3, 4, sorry, 5. Keep it open. So I agree with the open. I agree with the open. This has to be closed, though, because f prime is 2. That's a positive number.
But for those, wouldn't it just be 0, so you could include it, like, in the...
That's the idea, that 0 is neither positive nor negative, so in a way, then they're like, you can include it in. I would agree with keeping the intervals open at the zeros. That's how I've always been taught, and that's how all the workshops I've ever done have always shown it. But this one does need to be closed because this is not an ambiguous in between positive and negative. This is a positive value. Does that make sense? Okay. With that, kiddos, let's go ahead and 15 minutes to catch up with period 1 from yesterday. Turn to number 4. No calculator on number 4. On your marks. Get set. Pause. It's a potato, but who cares? Look for the calculus and go. It's a potato, but who cares? Look for the calculus and go. Yeah, it's to the negative 2/3 power, u to the negative 2/3. Yeah, I know. A lot of people do. All right, so they're taking a quick picture of this answer key, and then get out your calculators, number 1. Get out your calculators, number 1.
Because I was thinking you had to do like G prime and U sub, and whatnot.
No, because it's dg. It's like with a y and dy. It's like a y and dy. They like to throw that g in there to confuse you. All right, we're going to number 1.
Don't start the timer yet. Okay, you can start the timer.
I'll let us have almost all 15 minutes. But then I will once again show you the answer key right before the bell rings. You guys take a picture. Grade both tonight. Bring them tomorrow with questions. Sound good? Are you finishing the other FRQs tonight for homework? No. You're saving it for in class for us to do the simulated 15 minutes, but you can work on practice exams, studying your forevers, and when you see, you think. Calculators out and open. Go. All right, take a picture before you leave. Make sure you have for tomorrow number 4, number 1 graded. Work on when you see you think, studying your forevers, printing off a practice exam. Sorry I didn't get that email to you yesterday. I'll try to get optional number 4 out today. All right, bye guys.